Bismillahirrahmanirrahim. Assalamu alaikum. Today we will perform experiment number 8 to assemble the capacitive AC bridges for electrical measurement systems using discrete components. First of all, we will have a look what is Hay bridge and what is the usage of this bridge. Hay's bridge is used for the unknown inductance calculation. To measure the unknown value of inductance of Hay's bridge for electrical measurement systems using discrete components. This is the main objective of our experiment. Next, we will be seeing what apparatus we will be using in this experiment. We will be using discrete components consisting of resistor, capacitor, inductor, AC voltage source, function generator, our detector, that will be our scope, and NI board. In Hay's bridge, the capacitor is connected in series with the resistance, and the voltage drop across the capacitance and resistance are varied. And in Maxwell bridge, the capacitance is connected in parallel with the resistance. Thus, the magnitude of the voltage passed through the resistance and capacitor is equal. These are the formulas for the calculation of unknown inductance and unknown resistance. We will be calculating our unknown inductance from this formula. L1 is equal to R2 R3 C4 over 1 plus omega square C4 square R4 square. Omega is equal to 2 pi f, and f is our frequency that will be known from our oscilloscope. And unknown resistance calculation is from R1 is equal to omega square C4 square R2 R3 R4 divided by 1 plus omega square C4 square and R4 square. Steps we will be using to perform our experiment in the laboratory. First of all, we have to construct our circuit on NI board, and these are the values for our known resistances and capacitances, and we will be using L1 as 1 microhenry from the laboratory. Then we will follow these steps in order to calculate our unknown inductance. We have to fill up this table while performing our experiment. L1 is the given value. We need to perform this experiment for 3 different values of our inductance, which we will be using from our laboratory. R2 at null detection condition and R3 at null detection condition. R2 R3 are our variable resistances. R4 and C4 are fixed order resistance and capacitor respectively, and L1 again from our calculated value, that is from the formula. Then we will be calculating our percentage error. This is the formula for the percentage error: measured value minus actual value divided by actual value multiplied by 100. Measured value means the value which we will be measuring from our instrument or our measuring device, and actual value is the value which is taken from the laboratory, like 10 ohms, 10 kilo ohms, or 1 microfarad or 1 microhenry. Let us see how this experiment is performed in our laboratory. To measure the value of unknown inductance of Hay's bridge for electrical measurement systems using discrete components, let's have a look towards the circuit diagram. This is the Maxwell bridge, and this is our Hay's bridge configuration. There is a difference between the configuration of Hay's and Maxwell bridge. The purpose is same, that is to calculate the unknown inductance. C1 and R1 are connected in parallel in Maxwell, but in series in the Hay's bridge. That's why our Maxwell formulas are relatively easy as compared to the Hayes bridge, and Hayes bridge formulas are a little bit complex compared to Maxwell. Here are our inductive parts multiplication equal to the uh, discrete fixed parts. These are the formulas for the calculation of unknown inductance and unknown resistance. You can see a difference. As previously we have calculated from the Maxwell bridge that are relatively easy. This configuration is simply applied on our breadboard. This is the inductance and this is the resistance in series, and here is our variable resistance. This is the variable resistance in series with the capacitor. And this configuration, we have applied an input of sinusoidal waveform of the 100 Hz frequency, 5 volts peak to peak amplitude, and then we will run this, and at output we will be observing this on the scope. We have set 5 milliseconds time per division and 1 volt scale volts per division. And you can see this output waveform of the 100 Hz. At input we have applied our function generator, and this is the function generator. Here is the connectivity of the function generator, and now this is between the point B and point D in the lab manual. We will be connecting our oscilloscope, and then we will be finding our values from these formulas. Now you can see 3.314 volts peak to peak with a frequency of 100 Hz. The waveform is displayed on the oscilloscope. We will vary the value of variable resistance, and you can see a gradual decrease in the voltage, and at 82.4 millivolts the bridge is balanced. It is almost near to 0 volts. At this particular stage we will be filling up our table. R2 value we will be measuring with the DMM, and R3 value, and R4 and C4 values are fixed, and L1 from the calculation, and L1 which we have taken from the laboratory, and then we will be calculating our percentage error. We have to fill this table for 3 consecutive readings with different value of the unknown inductance. Thank you.